Today I will be showing you how to solve for acceleration when given two masses for an Atwood machine problem. First, we write down our known values for m1 and m2. We write down what we are solving for, which is acceleration. Then we draw out our free body diagrams. As you can see, they're very similar except for the fact that m1 is heavier, so because of this, it will be going downward while m2 will be going upwards. We then use Newton's second law equation to solve for acceleration. First, we'll start with mass 2 and see that F net in the y direction is equal to tension minus m2g, which is then equal to m2a. We can rearrange this for tension to see that tension is equal to m2a plus m2g. We then move on to our first mass and see that F net in the y direction is equal to m1g minus t, which is then equal to m1a. We rearrange this and also plug in the equation we got for tension, so m1g minus m2a plus m2g is equal to m1a. Then we rearrange this again to see that m1g minus m2g is equal to m1a plus m2a. We then factor out g and a to see that g times m1 minus m2 is equal to a times m1 plus m2. Then isolate a and get a is equal to g times m1 minus m2 over m1 plus m2. We then plug in our known values for gravity and mass and simplify, and then once you multiply and plug into a calculator, you should get 3.27 meters per second as your answer.